10.5, trigonometry and area. We are continuing on finding the area of regular polygons. This time, these polygons do not have special right triangles. So what do we do when we don't have special right triangles? We use trigonometry, SOHCAHTOA. We know the area of a regular polygon is 1/2 times the length of the apothem times the length of the perimeter, and perimeter is just the number of sides times the length of a side. So let's look at our first example here. We have a regular nonagon with 10 centimeter sides. So just like every other problem, we know we need N, S, and A. We know that our nonagon has 9 sides, and our side length is 10 centimeters. Then we draw our triangle using our radii in the center of the circle. And we break out half of that triangle to be our special right triangle. We need to know the measure of our central angle. So we take 360 divided by 9, and that gives us 40 degrees for our central angle. But we want to go further than that, so we divide that by 2, and we get 20 degrees for this angle right here. We draw our triangle, mark our 20-degree angle, mark our right angle, and this also tells us, we use triangle angle sum theorem, that this is going to be a 70-degree angle. We want to find this length right here is the apothem. We know that this length right here is 5. That is half of the side length. We are only using half of our triangle. If we're going to use trig, we need to mark our angle. As you see here, they used the 20-degree angle right here, which means that this is opposite, this is our hypotenuse, and this is adjacent. So we have adjacent and opposite. That means we're going to use tangent, and they write their formula, tangent 20 equals opposite over adjacent, 5 over A. Turn this into a fraction, cross multiply, divide by tangent of 20, and we have A. Now remember, these are irrational numbers, so unless you want to keep some very long decimals, you should just keep A in this format. Now, I like to look at my options and say, well, that puts my variable on the bottom, and I'm not overly fond of that. So let's look at the 70-degree angle there. If we mark the 70-degree angle, this becomes opposite, this becomes adjacent, and I can write tangent of 70 equals A over 5. This gives me A equals 5 tangent 70. Again, I'm going to keep it this way because it is irrational. And then I can simply just put that value, just like they did here, into my formula. Area equals 1/2 area times perimeter. Perimeter is just N times S. 9 sides times a length of 10. We can also do area equals 1/2 times 5 tangent 70 times our 90. And if we run that through our calculator, we are going to get exactly the same answer as they did. I think that way is easier. Pause your video and try the next example. In our example, we were told we had a regular pentagon with 4-inch sides. Pentagon means n equals 5. Side length is 4 inches. And so we draw our triangle. We find our central angle is 72, and the angle of our little triangle is 36. Now I know that I like to use the other angle, so I do triangle angle sum theorem, find out that is 54 degrees. Tangent of 54 is the apothem over 2. Don't forget that the length of the side of the triangle is 2. It's half of the side length. I plug that in for my area formula, and I get 13.8 inches squared. Don't forget, area is always squared. All right, let's look at another example here. We are told that a stop sign is a regular octagon. We know we need N, S, and A. So octagon means N is 8, and it has a 16.2-inch radius. Oh, that is new. Don't forget the radius goes from the center to the vertex. So that is our 16.2 length. Now we want to find the area. It means we're going to have to find a couple of more pieces of information. We need the apothem and the side length. So if we do a 360 divided by 8, we get 45. You take 45, divide it by 2, you get 22.5 for the top angle of our triangle here. Now, if we're going to use that angle, we look and we see that this is opposite, and here we have our hypotenuse, and this is adjacent. I know that anytime I have a hypotenuse, I'm going to use sine or cosine. So let's find the opposite length first. So I'm going to use opposite over hypotenuse. That gives me sine of 22.5 is x over 16.2. So my x value is 16.2 sine 22.5. And then I need to find my apothem. So that is adjacent over hypotenuse. That's cosine apothem over 16.2 over the hypotenuse, and I get my A value. Now, side length, so we have A over here. We can fill in A is 16.2 cosine 22.5. Now we need a side length. We found that the bottom of our triangle here is 16.2 sine 22.5. That is just this little length. To find our side length, we need to multiply that times 2. So this becomes 32.4 sine 22.5. So our side length is 32.4 sine 22.5. Now we simply put all of that into our area formula. Don't forget that perimeter is just the number of sides times your side length. Throw it all into our calculator, and we get the area of the stop sign. Pause the video and try the next example problem. Okay, this problem says we have a regular decagon with a radius of 9.5 inches. So we know that n equals 10 for a decagon. We draw our triangle, and we put 9.5 here at the radius. So again, we need to find the apothem and the side length. Now you find your central angle, 360 divided by 10 gives you 36. Find the angle of our triangle, 36 divided by 2 is 18. You can use the top angle, or triangle angle sum theorem gives us the bottom angle is 72 degrees. I used that one this time. If I'm using 72, I mark my angle. I label opposite, hypotenuse, and adjacent. And I see that I am going to be using sine and cosine because I have a hypotenuse. So I used sine to find the measure of the apothem, 9.5 sine 72, and I used cosine to find the bottom length of my triangle, which is 9.5 cosine 72. And then we remember that the side length is 2 times that. This triangle here goes on out to here, and this gives us our side length. So we need 2 times that. I take those numbers, put them into my area formula. Don't forget to multiply by 10 for your perimeter. And I get 265.2 inches squared. If you use the 18-degree angle, you will get the same answer. All right. We like shortcuts. This is a nice shortcut. If we are looking at this triangle here, and we have sides A, B, and C, and an unknown height H, I look at this and have a right triangle. Now, if I redraw that triangle here, I know that this measures C, this measures H. If I am looking at angle A, this is my opposite, this is my hypotenuse, this is adjacent, so I know I'm going to be using sine. The sine of angle A equals H over C. So I can use this to find my height. Height is C times sine of angle A. Now if I substitute that in here for height, C sine angle A, I now have a base times a height. So my area becomes 1/2. The length of the base is B, and the length of my height is C sine angle A. We just proved our last theorem here. The area of a triangle given SAS. Okay? You can find the area of a triangle, which is half the product of the lengths of the 2 sides and the sine of the included angle. We know side angle side requires included angle. So if I have the measure of angle A and the length of the 2 sides, so that that angle is included, I have a formula to find the area of that triangle. So let's look at an example here. I have a triangle. I have an angle. It is included between these 2 sides. So A, B, and C. And I simply put those into my formula. 1/2 A, B, sine 48. Put it into a calculator and get an answer. So pause the video and do the next example.